Hello, students of science. Let's talk about ideal stoichiometric calculations. As we've already talked about with stoichiometry, we are going to be using that to figure out the relationship between reactants and products. A balanced equation is key to solving these because we get our mole ratio from that. So in this case right here, I have a mole ratio of 1 mole of methane is going to react to form 1 mole of carbon dioxide. Or 1 mole of methane is going to react to form 2 moles of water, or 2 moles of oxygen and 1 of CO2. So all those ratios that we've seen before. Now, in order to get from the mass of a given substance to the mass of an unknown substance, we need to cross what is called the mole bridge. Here's the way it's going to work. I'm going to be given a question where I'm saying, hey, I have 30 grams of this substance. How many of this substance is it going to make? Well, in order to get there, I need to use the molar mass to convert between the mass of a substance to the amount of moles of a substance. Then I'm going to multiply it by that mole ratio to get the amount of unknown substance in moles, and then convert that to a molar mass to my unknown substance. I also can go from the volume of a given substance in liters to convert that into moles and continue that along. I could also go by the number of particles of a given substance and convert that into the number of moles and so on. And of course, I can use that on the other side as well. But all of these right here are key upon this mole ratio, this mole bridge. In order to get from one side to the other, wherever you're going, you have to cross this mole ratio. Without it, you shall not pass. Let's do a mole-to-mole conversion. And for the purposes of your notes, I want you to copy this down, and we're really only going to focus on these middle ones here, but I want you to copy this down once, and we'll use this as an example from there. So let's say I'm doing a mole-to-mole conversion. I'd like to have carbon dioxide reacting with lithium hydroxide to make lithium carbonate and water. And the question is, how many moles of lithium hydroxide are required to react with 20 moles of carbon dioxide? Well, moles of lithium hydroxide is my unknown. That's what I'm really looking for right there. And what I'm given is 20 moles of carbon dioxide. So what I'm trying to do is I'm trying to go from one amount in moles to another amount in moles. In this case right here, I am trying to go lithium hydroxide and carbon dioxide. And the mole ratio is 2 moles of lithium hydroxide to get to 1 mole of carbon dioxide. All I need for this is a mole ratio. Everything else is kind of secondary from what I'm looking at. All I need is the mole ratio when I'm going from 1 moles to another moles, trying to figure that out. Let's look at mole to gram conversions. So I have an example of magnesium plus oxygen is going to make magnesium oxide. And the question is, how many grams of magnesium oxide are produced from 2 moles of magnesium? So my unknown is grams of magnesium oxide. I'm looking at that. My mass in grams is produced from 2 moles of magnesium, and that's my given. So all I need in this case right here is I'm trying to go from a given substance in moles, right here, 2 moles of magnesium, and I'm trying to get my mass of my unknown substance. So I'm going from 2 moles to grams of my unknown substance. All I need for that is the mole ratio and the molar mass of my unknown compound. In this case right here, that's just these 2 steps. Everything else, not necessary for this calculation. So I'm going from moles to grams. I need the mole ratio and the molar mass of my unknown substance. Let's look at gram to mole conversions. Ammonia plus oxygen is going to react to make nitrogen monoxide and water. I have 824 grams of ammonia and lots of oxygen, so we don't even need to worry about that. But this much ammonia, how many moles of nitrogen monoxide? So I'm going to be looking at my unknown as moles of nitrogen monoxide, and my given is 824 grams of ammonia. So here's where I'm starting, the mass of a given substance, which is right here, and I'm trying to get to moles of nitrogen monoxide. So I'm trying to get to here. All I need for that is my molar ratio, which I always need, and the molar mass of a given substance. Everything else is not going to be important. So I'm just going to look at where I'm starting with, mass of my given, trying to get to amount of unknown in moles. There I need the molar mass and the mole ratio. Finally, when I'm looking at gram to gram conversions, let's look at this example. Ammonium nitrate is going to break down to form nitrous oxide and water. The question is, how many grams of ammonium nitrate are required to produce 33 grams of nitrous oxide? Here's my unknown, grams of ammonium nitrate. That's my mass of my unknown, and I'm trying to get 33 grams of nitrous oxide to make that. So I'm going from a mass of a given substance, which is right here, to get to a mass of an unknown substance, which is right here. To do that, I need the mole ratio, of course, molar mass of my given substance, and molar mass of my unknown substance. Everything else is going to be hidden. So while I do have this really big complicated thing right there, I only need to look at using parts of it. Here I'm going mass of a given to mass of an unknown, and I need these three pieces of information to get there. When we start working some examples, this will become a little bit more useful.